Hello, everyone, and welcome back to the live series on geospatial analysis using Python. Hello, I'm your host Krishna, and I'm really glad to begin this series again. Last month was very surprising for me. I There was a lot of things that happened in the life, but then that's fine. We are back on track, and I hope you guys are practicing Python, whatever we have learned, and not just from this series, but from anywhere that you find good content from. There are such amazing teachers available online, free of cost on YouTube. They have written great blogs, great books as well. I will highly recommend you guys to keep checking these different things and keep learning Python every day. All right, back to the topic. So today we are going to deep dive into one of the most important concept in Python, known as OOPS concept. It's the short version of object oriented programming, and even though it sounds like really serious and really complicated, believe me, it is not like that. Of course, to understand it, we might need a little bit more practice, and we might need to uh, learn a lot of things and practice it a lot. But at the end of the day, again, this is just a concept more than coding itself. So we are going to focus more on understanding OOPS, because this is a concept, and then, as you know, that once you understand a concept, you can use it in n number of languages. So let it be C, C sharp, Java, whatever language that you prefer, OOPS is going to be there. Alright, so now let's begin the discussion of OOPS. So what is exactly OOPS? Before getting into the Python version of it, we will take a look at the real life example. So if you consider the world that we live in, everything over here is an object. What do we mean by that? So for example, if you decide to go from one place to another, you will either take a road, so you will take car, or maybe you will take ship, or maybe you will take flight. So these are objects. So car is an object, then ship is object, aeroplane is object, everything is object. If you decide to write something, you will use notebook and pen. Both of these things are object. And even let's consider a living thing. So if you have a pet, that dog or that cat or even that snake is going to be an object. You yourself is also an object. So everything that we live in the world is an object, and then we use this object every day. So for example, each of the object, let's consider your favorite animal, let's say a dog. So when we say that dog is an object, when we say that dog is an object, that means that there are some characteristics that defines that object, and then there are certain things that that object can do. So for example, if you take an example of a dog, there is going to be some characteristics. So what is the color of the dog? What is the color of the dog? So let's say it's dark brown color. And what is the height of the dog? Then uh, then what is the length of the dog? What is the breed of the dog? So all these things are characteristics of that particular object, also known as properties or attributes in a programming term. So these are all the attributes of that object. So if you consider car, so car will have attributes like its color, then its manufacturer, then how many wheels are there, then probably how many seater the car is, and so on and so forth. So these are the characteristics. And then there are some behavior of that object. So if you consider dog, then barking is one behavior, walking is one behavior, swimming is one behavior. Same way, if we consider car, then driving is one behavior. Then maybe if your car has a uh, something, if your car is like a Thar or open Jeep, then you can open the hood. That is again one behavior. So these are all functions or behaviors. In programming terms, it's methods. So functions and methods are, we can use them interchangeably. So I will tell you when you should call a function and when you should call it as a method. But now you get the idea, right? So we have an object, everything in the world is object, and then object will have a property and a functions or their behavior. So let's consider a very simple object. Understanding object. So let's say that there is an object known as mobile. So mobile is an object where then attributes. Now I'm going to use terms that I want you to use whenever you talk with anyone regarding programming, because if you say properties, this is not going to sound more like a programmer's language. Attributes, definitely. So mobile will have attributes such as color, then display size, then the make, and what else, number of cameras. So these days people are going very crazy, increasing number of cameras in the latest phone. So these are all attributes. And methods or functions can be calling, sending text, playing video, so on and so forth. So these are all methods related to the object. But now consider this thing. Now when I'm talking about a mobile, let's say I have a very simple phone. Let's say I have iPhone 11. Okay. So when I say that I have iPhone 11, then I can, so if I say that iPhone 11 is my object, then I can simply define its attributes, right? So I can have color, white, camera, 2, make, Apple, so on and so forth. And obviously I can define calling is will, call, contact, so on and so forth. But think about it. The more important thing that I want you to focus on is that this is not the only one iPhone 11 in the world, right? So as I have iPhone 11, there are millions of other people who has iPhone 11. That means if we consider the company Apple itself, what they did is they basically created a wireframe. They basically created a blueprint of iPhone 11, and then they shipped that blueprint to their factory, let it be in China or in India, wherever. And then they asked that this is our blueprint, now start creating object for us. And then in each object, they also defined that okay, in this particular object, I want my iPhone to be of white color. Then in some another object, I want that iPhone to be black color. So I hope you're getting the concept. So we have one blueprint of how to make stuff, and then we have the object where the object will be a specific individual stuff. So I hope this concept is clear to you guys. And now this class is actually your blueprint. So we have understood the object, and now the second important thing that we have to understand is class. So understanding class. Now as I said, class will be a blueprint. So it is a blueprint based on which object will be created. So I hope this concept is clear to you guys. So as I said, there will be a class of iPhone. So if I add one more markdown here, relation between class and object is that there will be a class of iPhone created by Apple, and then there are objects. So you can see that class is singular while objects means it's plural of iPhone manufactured. And then here each iPhone will have different characteristics or different attributes, but the class will be same. So class will define all the attributes that are going to be there, and then object will have value for those attributes. So I hope at least the concept of this is clear to you guys. Let me know in the chat box if you're stuck somewhere, or if you are having problem understanding the theory behind class and object. If this is fine, we can definitely move up towards the programming side of class and object, because class and object is one of the most important thing. this is basically building block for oops concept. Once you understand this, then I will go ahead and tell you how exactly this class and object thing is used in programming world. So please write down in the comment if you guys have any questions. Okay, let's move forward now. So now what we will do is we will actually see this class and object working in Python. Now, to define a class, there is a keyword reserved in Python known as class itself. Okay, so if you remember in our previous videos, we saw how to create functions. So to write any function, we do def, right? So to write for loop, we use for or while. Just like that, to use a class or to create a class, we will use the function, we will use the keyword known as class. Now let's say that I will define a class as man. Okay, so this is my class name, and then I will use colon to get inside this. Now inside this, as I said, that class will have attributes and methods attached to it. So here we saw that object has attributes and method attached to it, but now we understood that object is nothing but just a instance of class. That means obviously classes will also have attributes and methods assigned to it. So let's start with a very simple method. So when we say class of man, I want to define a method which will enable him to speak. Now I will write def. So by looking at def, you might think that okay, def means a function. But now here is the trick. When the function is inside class, then we call it as a method. When the function is outside class, then we call it as a function. Okay, so def speaking. Okay, and then I will pass self, and I will come back to it why I have used this self, and then I will simply write print he. Okay, as simple as that. So now you can see over here that we have defined a class of name man, and then we have written one method inside it. Okay, we haven't described any attributes as of now. We will see that how to do that very shortly, but for now let's just stick with one very simple method known as speaking. Generally, if I just copy this and if I use it uh, in another row, let's say I make it as a very simple function, then I can simply go ahead and then create a function, right? So I will remove this markdown, and then I can simply do speaking, and you will know that we'll get he. It is very simple. This is what we are doing till now. But now this function is inside this. That means we cannot directly call this function because this is not a function. This is a method, and this method is only accessible inside this class. So whenever we will create an object based on this class, then and then only we can use this speaking method. Okay, what do I mean by that? Now we will define object based on class. Okay, now we will do a very simple thing. Let's say Aditya is equal to man. Now you can see that what exactly we did here, why exactly we have written man, and then why there are parentheses over here. Now let's consider any another variable, a very simple variable. Let's say name is equal to Shyam. So when we do this, this means that this name has a type, and this type is of string. If I do marks, let's say 90, that means the type of this marks is integer. Just like that, these all types, if I do type of marks, you'll see that I get int. Just like that, man is now again a type of input. So string or integer, this is also a type of input. That is why we add it like this. And now when I will do type Aditya, you will see that we will get the type main.man. Just like that, if I do type Sham, I will get string. Just like that, we will add Aditya is equal to man and then colon. I will get to you why we use this colon very shortly. But then this is how we will define an object. Now this Aditya person is a copy. Now this Aditya person is a copy of the class man. That means whatever we have inside man is now accessible to this variable. That means I can do something like Aditya, and if I put dot, you will see that we got speaking over here. So that is the advantage of using a very good IDE. So I will highly recommend you guys, whenever you are working on real life projects, you have to be sure that you are not using a very simple IDE, but try to use an IDE which will be interactive and which you can use. So which you can use, and obviously that can give you a good suggestion. So for example, here what we did is, when we assigned this Aditya to object to the class, it automatically understood what is going on, and then it took all the attributes, all the methods available inside man, and then it is basically presenting us. So if I do speaking now, and if I hit enter, you will see that we got hey. So this is how object can use the data or methods or attributes inside a class. So I hope this is clear to you guys. Any problem till now? Please keep asking problems in the comment box so that I can have a look at it and answer to you whenever possible. Okay, let's move forward. Maybe we can add a couple of more attributes to it, that def name and then self print hi, my name is Krishna. Okay, now if I do Aditya, even though the name is Aditya, it is going to spell the name as Krishna because this is static. And now here is how we will make it dynamic. So how do we make this dynamic? How do we write it in a such a way that we can actually pass some data when we are initiating an object, and then we will use that data throughout our object journey. So to do that, exactly why we use self. So what do we mean by self is that whenever this class whenever this class will be used to create object, this self will actually mean this object itself. Okay, if it's a little bit confusing, don't worry, we will see what exactly do we mean. Now there is one compulsory method that we have to write whenever we want to add a variable, to the class. So we do it by using def and then init. And now here we will write self and then whatever number of variables arguments that we are expecting. So let's say name and location. And now what we will do is we will do self dot name is equal to name. So what are we doing over here is that we are saying that inside this object there is one variable name. Now this is not a rule that this name and this name has to be same. We can also do a and b, that is not a problem, and we can then define a. And similar to this, we can do self dot location is equal to b, and then this will work just as fine as well. So this is how we will define arguments when we are defining an object, and then we will use those arguments in our application. Okay, so now I have defined it and now I can use it. My name is self.name. Okay, now how do we use this is that we will create a new object. Let's say over here we will do Tom is equal to man, and then the name is Tom and the location is let's say India. Okay, and now okay, let's see what's going on. I think we haven't saved this. Okay, now you can see that Tom is a instance of class man, where the A variable is Tom and the B variable is India, and as soon as we initiate this instance, we immediately take these arguments and then we assign those arguments to a variable known as name and location. That means now if I do Tom dot name, I think there will be a confusion because the method and the variable both are of with the same name. So I will do get, or maybe my name, and then I will save it again and use it over here. Now when I do my name, you will see that I got, hey, my name is Tom. So like this we can use arguments to actually create instances from the class. Now I think you are getting the point what we were saying over here, understanding the relationship between class and object. So you can see now this is a class. So for the same class, for the same man, now we are creating different objects. So we can also have Ram, and then the name is Ram, and let's say location is again India. So again I can do ram dot my name and I will get that my name is Ram. Just like this, consider that we will create a class for iPhone, and then we will have color, camera, name, model, etc. And then whenever we will define a new object, we will pass all those values as arguments, which we will then use wherever we want throughout the code. So I hope this is clear to you guys. Here we can also do tom dot name, because as you can see that we do self dot name, and as I said, self means that object itself. So that's why I can do tom dot name and also tom dot location. So if I do location, you will see that hey, my name is Tom is the output of this, and then tom dot location is India itself. Okay, is this clear guys? Is there any question till now? Please keep adding the questions in the chat box. Okay, just like this, there might be some time where we want to use a variable, and we want to define a predefined value for that variable. So for example, the name itself, let's say that we are not sure whether we are going to use whether our user, when they are defining an object, are going to give the name or not. So what we can do in that case is okay, let me make some space and write it down. I will delete this, I will delete this, and also this, and now we'll write one more class, man, let's say woman, and now we'll do def init self, and we will define that A by default is empty and B by default is empty, and then we can do something like self dot name will be, let's say Siddhi. Okay, and then self dot location is Nasik. Okay, so I have predefined the values. That means if you don't provide a value, we will use these values. Okay, I will simply copy this from here because this will save some time for us. Okay, I have defined a class, and then let's say random. So when I have random, then that means there is no name or I don't know the name. So then we will use the name which is predefined. So if I do get name or my name, then I will get the name Siddhi over here. So this is how we can add a default value to the variable. Okay, is this clear, guys? Now we will see how we can use multiple objects together. So using multiple objects together. Okay, maybe we will add one more attribute over here known as age. Okay, maybe I will simply copy this and then I will paste it over here, and now we only have age. Let's say that's all we have. Okay, self dot age is equal to age. And now what do we want to do is we want to compare. So def compare who is older, and over here now we'll pass self and then other object. Now what are we doing over here? Let's see. Now obviously when we are doing comparison, that means it is going to be a comparison between at least two different objects, right? So what we are saying over here is that take this object itself as the first argument, and then the second argument, which is what we will pass to use for this specific function, and then we will do something like if self dot age is greater than other object dot age, then we will simply print you are older, else we will print she is older. Okay, is this clear, guys? What we have did over here is we have defined a class init function to initiate the class, and when we do the initiation we'll take the age argument and we will use it for the variable age, and then we have defined a method who is older where we take this object itself as one argument and another object of the same class as another argument, and then we do the comparison to print. Okay, so I will define this class, and now I will have Reena as woman with the age 34, and then Vrush as woman with the age 28. Okay, if I define these two objects, then I can do something like Reena dot who is older compare with Vrush. Okay, if I do this, you are getting the message that you are older. So obviously we are actually using Reena as the first argument and Vrush as the second argument. If I do exactly opposite, so if I do this dot who is older Reena, then I will get she is older. Okay, so you can see that this is how we can compare, or this is how we can write functions in classes itself which we will use to do some comparisons and things like that. Now let's try to understand the variable types available. Variable types in OOPS. So we have instance variable and class variable. So far you can see that we were using this self dot something, which means that this is instance oriented. This self means whatever object that we create based on this class will actually have this variable. But then there will be some variables which are class oriented, so those will be true throughout the class. Okay, so consider this: when we will create a class of mobile, let's say if it is an iPhone, let's say that if we create a class of an iPhone, then the company that has built that phone, obviously that will be same throughout the piece. So let it be iPhone 12, iPhone 13, anything like that, but the company is going to be same all the time, right? It's going to be Apple all the time. So this variable will be a class variable rather than being an instance variable. Okay, now let's see this in action. Okay, so we will do class iPhone. Okay, and then obviously we'll do the traditional stuff. We'll do def init self model color. Let's say we'll just do these two, and then we'll do self dot model is equal to model, and self dot color is equal to color. Okay, simple. And then we will we'll simply check this def which phone self, and then this will tell us that print this is a comma self dot model. Okay, very simple. But now here we have to define a class variable. So far we were defining a instance variable. So you see that self dot model, self dot color, these are all instance variable. Now if I define variable outside this method, so over here let's say make is equal to Apple, now this becomes a class variable. Now we can use this class throughout. So to use this class we will again use self only. Okay, so I will do plus which is of plus self dot make. Okay, so what is happening over here? So you can see that make is a variable of a class, but then when you will create object from this class, everything that is inside this will be used for that object itself, which also makes that this variable as an object variable itself. Now if I save this and if I run this, let's say I create i11, and if I do iPhone 11 white. Now if I do this, if I check the make, I will be able to see that variable. Okay, so you can see that I got as an Apple, and obviously when I do i11 dot which phone, I will get that this is a iPhone 11 which is of Apple. Okay, so you understood the difference between class class based variable and instance based variable. If it is not clear yet, let's try to see this. If I try to make some change to this make over here, okay, so if I do one more method, let's say def set make self, and then obviously it is going to take new make, new name, and then if I do self dot make is equal to new name. Now if I do this again, if I do which iPhone, and then I run this i11 dot set make, and then let's say if I pass the name Samsung maybe, and then if I run this again, you'll see that we got set make. Okay, there is no Okay, so you can see that we got first, this is iPhone 11 which is of Apple, this is iPhone 11 which is of Samsung. Now what happened over here is that this change has been made just for this instance only. So if I try to make one more instance, so I12 is equal to iPhone, iPhone 12 black, and if I again do the same thing, I12 dot which phone, you'll see that we got, this is basically Apple phone. So this is how we will get the idea about which basically which is the instance variable and which is the class variable. So the changes that we make will only be available for this, and then this will be available throughout. So if I make the change over here, let's say something like banana, maybe just for fun, now you can see that we'll get banana. Here again we'll get banana. So this is a class variable, not a instance variable. So I hope this is clear to you guys. Now what did I exactly did over here? I did set make. So this is known as a setter. So there are specific methods known as setters and getters. So get means getting the data. So far if I do something like iPhone 11 dot model, you will see that I am still able to see this data, but generally this is not a good practice. So what do? We do is we basically write getter functions like def get model self, which will have a very simple job of returning self dot model. That's all. So is it does the same thing, but just it looks very professional. So because you, when you do this get model, the user, the developers will have an idea that what exactly you're trying to do over here. Same thing we can do with the set. So there are getters and then there are setters. So make sure that whenever you're writing your own classes, you use things like init. Obviously you're going to use it whenever you will use arguments, then getters and setters to get the data back. Okay, so I hope this is clear to you guys. Okay, now let's move forward and understand types of classes, types of methods, sorry. Again, there are three types of methods. One is instance method, then there is class method, and then there is static method. Okay, so far whatever we have seen, we are using self, which is basically representing a as a instance method, because these methods are instance oriented. These are not class oriented or not even static. Okay, so what do we do now is we will get we will see a very simple example. Let's say we go with the class man. Okay, and then we define a class variable planet. It belongs to earth, and then we do basic things: def init self name location self dot name is equal to name, self dot location is equal to location. Okay, now what we'll do is we'll try to do something very funny. We'll try to change this uh, class variable. Okay, so we can do something like def object set object planet. Okay, and then we'll have self and then the value itself, and we'll do self dot planet is equal to value, and then we'll print it again. So print self dot planet. Okay, if I do this and let's say row is equal to man, name as row, location as China maybe. Okay, and then we do row dot set, maybe let's first try to print the planet. You see that obviously this is Earth, and now we do set object planet Mars. You see we got Mars, and if I do row dot planet, this is now Mars. Okay, so this is how it is changed for this instance. Now there are some methods that we can write for the class itself, and those are used by first declaring a decorator by @sign known as class method. So now this is a class method. Okay, so we can do something like def set planet, and now instead of self this will be CLS, which means that take this class and then planet, and then we'll do class dot planet. Now you can see that we are not doing self dot planet, we are doing class dot planet, and then we will do planet itself. So planet now is this. Now we can write a getter function. So if you remember, I have told you about setter and getter. So this is a setter function where we are setting the value, and obviously we will print this again once this is set. So cls dot planet, and then there is a getter function. So def get planet, and since this is also going to be a class method, we will write class method print cls dot planet. Okay, now let's try and test whatever we have written. Okay, now I will do a very simple thing. Let's say Joey is equal to man, name is Joey, and place is Denver. Okay, if I now do Joey dot planet get planet and Joey dot set planet to something like Neptune maybe. Now you can see that we got Earth and then we got Neptune. Now if I do the same thing again, Rick is equal to man, the name Rick, and location let's say London. Now if I do Rick dot set object planet as Mars, Rick dot get planet, and one more time we will try to set it to something else, Mercury. So you can see that we got Mars, then we got Mercury, no, Neptune. So what happened, what exactly happened over here? Now you can see that when we did set object planet, we changed it to Mars, but when we tried to get the planet, we were, so this is exactly what we did over here, where then for this particular instance only this planet value was set to Mars, but when we try to get the value of the class, not the instance, then we will get whatever is the latest value set. So you can see we did Joey dot set planet as Neptune, so that means for here the get planet was Neptune, and then next time when we did set planet as Mercury, now from now on the class value will be Mercury. So if I do this one more time, now you will see that we'll get Mercury. So this is how things change. If I run this again, you will see that finally when we did the class method, we changed it forever to Neptune. If I run this again, you will see we got Mars, because we set it as a Mars, and that was a self dot planet, that was not class dot planet. So this is only valid for this instance, not for forever. But when we did get planet, we got Neptune, because here we did set planet to set the class variable forever. So you can see that this is the difference. And finally, we can also write some static methods. So static methods have nothing to do with the class or with the object itself. These are static methods where there are no uh, like no initialization of the class or object is needed. So I can write a very simple static method of, let's say, def wave, and then as I said that they are independent of class and object, so there is no need for us to provide argument. And then I can write print bye bye, right? So if I now execute this, then I can do something like joey.wave, and you will get the output as bye bye. Okay, as simple as that. So this is how exactly we see and we use different types of methods in the in a class itself. So we can create methods which are instance oriented, and you can see that for such types of methods there is no need of decorator. This is known as decorator. And for class methods we will use class decorator, and then for static method we will use static decorator. So this is how different types of methods can be used for a class. Now there is one more thing that we can understand is inserting class inside a class. Now this is not always necessary, because you can always have independent classes and then connect them with each other. But for some classes where there is no use of putting them in a global level, we can put that inside a class itself. So for example, if I have a class of course, I will first write a markdown adding class in another class. So I will do class course, def init. So we'll do self name length, and now inside this we will do self dot name is equal to name, self dot length is equal to length, and now we will define one more class inside it. So class of video. So you can see that there is no need of having this class video outside this course, because independently no one is going to use it, for example. Okay, and then we will again do def init, and then self, and then we can again obviously define so many things over here. Self dot name is equal to, let's say, start HTML, and self dot difficulty is equal to easy. And once this class is initialized, then we can use it anywhere. So I can do self dot video is equal to video class itself. Self dot video. Okay, so this is how we can define classes inside classes, and obviously then we can define methods based on that. So def get video name. For this then I can do something like self print self dot vid. Now this vid is for this dot the name. So this is how we got over here. Self means this object, vid is this variable which again is representing a class, and obviously not just a class but the instance, that means the object. And then we go over here, and then we got the name over here. If I run this and create a uh, web is equal to course of HTML, and let's say of the length 10 hours. Then I can do something like web dot get vid name, and then this will give me the video name start HTML. So this is how we can add a class inside another class. So I hope this is clear to you guys. Now we will see the concept of inheritance. Now what do we mean by inheritance? Inheritance means getting all that your that parent element has, and then also whatever you have. So for example, for me, whatever money that my friend has, I if I take that and I also have my own money, and then basically I inherit it from him. Okay, a very silly example. So good example can be, for example, if your parent owns some land. Okay, let's say if your father owns let's say 2 acre of land, and then you as their son or daughter, if you own your own separate 1 acre of land, you basically own in total 3 acres of land, because after your father, that property you will be inheriting, and then you will get that property as well. So this is what the concept of inheritance means. So let's just try to see this concept from a from a Python angle. So let's say if I define a class of basic calculation, and then I do 1 is equal to 0 and then 2 is equal to 0. So these are two numbers that we will take: def init self a b, and then we'll do self dot 1 is equal to a, self dot 2 is equal to b, and then I will write just one function to save the time, that def merge self will be printing self dot 1 plus self dot 2. Okay, so let's say I built this very basic class. Okay, there's nothing very fancy over here. So if I do the cal is equal to basic calc of, let's say, 4 and 5, then if I do the cal dot merge, obviously I'll get 9. Nothing new over here. Now I want to actually define one more class which has its functions, but it also has the function from basic calc. So what do we mean by that? So there are two types of calculators, right? One that we use in our daily life is the one where we can do basic arithmetic calculations, and then there is a scientific computer where we can do some scientific calculation but also arithmetic calculations, right? So in programming, if you want to create that scientific calculator, you don't necessarily have to also create this basic arithmetic functions or methods. What you can do is you can use this all these methods that we have in this class and then inherit this in another one. So how do we do that is by defining class advanced cal and then inherit everything that you have from basic cal. So this is how inheritance is defined. And then I will write a very simple, let's say, bracket square formula. Bracket square self, and then so we all know the formula for bracket square. So we'll do self dot. Now you can see that we have this 1, 2, merge, all these available. So this is how once we inherit, we will get access to everything inside this. So I can do self dot 1 square plus self dot 2 square plus 2 into self dot 1 into self dot 2. Okay, this is clear, guys. So when we are doing bracket square, it's a square plus b square plus 2ab. Okay, right? Now instead of calling this cal as an advanced cal of class, I will do it like this. And now you can see that merge is still working, but now I can also do square So if I do this, I got 81. So 16 16 plus 25 plus 40, we got 81 exactly. So this is how we can inherit the data from one class to another, and then this inheritance can go on. So now if I create one more class which inherits advanced class, then by automatically that will also inherit the base class. So the third class that we will define will have access to this data and also access to this data. So I hope this is clear to you guys. So this is some basic information about the OOPS concept. I hope this will make sense when you actually start creating some complex code where then you want to define your own classes and then use them to move forward. So for now, just keep on practicing these OOPS concepts, read some blogs, read some books in order to understand more about it. There are so many more things involved in this, like polymorphism, duck typing, and so on and so forth. Keep on exploring those things. Now we will move forward and learn one of the most important thing in Python, which is understanding the concept of modules. One of the reason why Python is so famous amongst developers is that you don't have to do everything from scratch. So consider this scenario. If you want to develop a data analysis application, or let's say a very simple application which works like an Excel, where you want to take some data, calculate the average of the data, or maybe the mean of the data, so on and so forth. Now to calculate this average or to calculate this mean, you don't have to necessarily create the functions or calculations on your own. You can simply import the modules either from a published library or your own Python files, and then use those functions uh, in your file. So what do we mean by that? Okay, let's just create a file known as simplemath.py. Okay, and in this file I will write a very basic functions: merge a comma b, print a plus b. Okay, like this I will write some more functions. So separate a minus b times, like that. Let's say if you have created your own formula, so let's say a very random formula, my formula a b, and then I do something very crazy: a star star 3 plus b star star 2 plus b minus a, some minus 1. Okay, something like this. Now these are all my simple math formulas. Now what do I want to do is, whenever I will write my own Python code, I want to use these methods. So I'm not necessarily going to copy this formula, or maybe let's say if I have my own, let's say work project1.py. Okay, now in this project file, if I want to use this formula, I'm not simply going to copy this formula and use this def over and over again. No, I'm not going to do that, because that will unnecessarily uh, increase the size of my file, and unnecessarily it will increase the complexity of my file. Instead of doing that, what I will do is I will import this file. Okay, now we are talking about import. Okay, so we have written some formulas, then also write some basic things like name Krishna, course Python. Okay, now what I will do is I will import this. So I will use import and then simple math. Import simple math. So you can see that I'm getting this simple math because this simple math is in the same directory where my project 1 is. If I have to move this simple math to, let's say, a folder, let's say my packages, and if I move this simple math file over here, then I will have to do something like import my packages slash simple. Now I think I will need to import it as my packages simple math, like this. So you can see that this is how we will import this entire Python script into this application, and from this moment forward then we can do what we usually do. So I can do something like my package dot simple math dot. Now you can see that we got merge, my formula, separate, times, and also access to this variable. So if I do course and if I run this, you will see that, okay, I will clear this a little bit, print. Now if I run this, you will see that I got Python. If I write the name over here, you will see that I got Krishna. Similarly, if I do my packages dot simple math dot merge 4 and 9, if I save this, run this, you will see that we got 13. So you can see that now we have access to all the functions, all the variables that we wrote in this file over here. But every time writing this my package dot simple math is not feasible, right? Because this looks very dirty. What we can do is then we can use the alias name for this. So I can do something like as SM, so short for simple math. By just doing this, I can replace all these my packages dot simple math in my code with SM and it will still work. If I clear the output and if I run it again, you will see that we again got Krishna and 13. So this is how we can import a file and rename it to something that is very short and understandable. Now sometimes you don't necessarily want to import everything from the file. Maybe you are just looking for this particular formula. Then in that case what you can do is you can write from my packages dot simple math import my formula. That's all. By doing this you will simply import that formula itself, and then you can do something like my formula and then pass the data 5 6, and then when you run this you will get 166. Now I don't even have to write this sm dot my formula because I have imported that particular formula. If I comment this line, both of these lines won't make sense because obviously sm will not be defined. So this is again one method about how exactly we can import something particular that we want from that file. And again we can also rename it to something like mf, and then this will still work fine. I can do mf 56 and then this will still work fine. Run it again and you will see that we got the data 166. So this is how importing module works. So far we have only imported files that are available in our local machine. Generally how Python world works is that we go to pypi.org, which is the home for all the Python packages that are built, and then we use the package that we want to use. So for example, the earlier example that we were talking about, that getting mean or median and things like that, there is a very good package known as NumPy. Now again, now we will focus more on how to understand that which package we have to download, and obviously how to download the packages. If you remember from our very first video, we understood the concept of environment, how to create environment and then install a package to it. Now this is the same thing. I hope you now these things are linking properly. When we work with NumPy, we will simply do pip install NumPy and then this will install the file. So what are those files actually? If you look at the source code, you will see that these are nothing but are going to be a Python file itself. So in a setup.py file, if I go over here, you will see that you will get more information. So this setup.py file and everything we need to do when we want to create our own packages. We will see that later in the course if needed, but for now we'll just simply understand this is that when we install any particular package, let's say pip install numpy, then we can use it exactly the same way. So we can do import numpy, and then this will work fine. We will not get any error. If I run this, you will see that there is no error. But if I try to import a module which I have not installed, so probably GeoPandas, if I try to run this, I will get an error that there is no module named GeoPandas. So in this GeoVenv environment, we don't have any module known as GeoPandas. So this is how we will import the modules, maybe as np. So this is the line that you will see in almost all the codes. Whenever someone will import numpy, they will use it as np. Whenever someone is importing pandas, they will do it as pd, so on and so forth. So this is how we actually import the existing libraries which are available and then use it forward. In the next video, we will get started with understanding these very awesome Python libraries and why exactly we need to learn this. Once you see these libraries, you will understand that the power of Python is unbelievable. People are creating such awesome things and building such awesome libraries so that every day your life becomes easier. So far, if you want to get started into machine learning, all the basic things that you need to do, you need to calculate the the mean, the average, you need to test your data. For all such things, libraries are built. So you can just simply import these libraries, understand their documentation and use their methods right away. So I hope this lecture was clear to you guys and helpful to you guys. Make sure that you are in the Slack channel and make sure to connect with me on LinkedIn, where I keep on posting more updates about upcoming videos. The next Tuesday, we will have a next lecture on Web GIS bootcamp, and then next Thursday, obviously, we will meet again for for the geospatial